Hey, scientists! Welcome to Over the Top Science. I'm Mr. Crouch. In today's lesson, we're going to learn about the three states of matter. We'll learn about each state, the properties of each state, how the molecules are arranged, and the different energy levels. Let's get started.
Okay, let's start out with our science journal. Open your journal and start with a new page called Three States of Matter. We're going to make three columns, and each of the columns will be one of the states of matter. So what are the three states of matter? Yeah, you guessed it, solids, liquids, and gases. So on the top of each column, you're going to put solid in the first one, liquid on the second one, and gas on the third one. So take a moment and catch up and pause the video. Solids, liquids, and gases are made up of these things called molecules, and the arrangements of the molecules will tell you if it's a solid, a liquid, or gas. And we're going to use circles to represent the molecules. So we're going to draw a diagram of a solid, and in a solid, the molecules are very close together. They're even overlapping. So you're going to draw circles just like I am, very close together, overlapping. All right, the reason I made these circles blue and the word solid blue is because solids have the least amount of energy. And I bet you can guess the amount of energy in a liquid and a gas. So let's write least amount of energy underneath our model of the solid. And the other thing we already discussed is the molecules are, or we can call them particles, they are tightly packed. So the particles are tightly packed together. And the one thing they do, they're very close, and it's almost like they're shivering. So they vibrate very slowly, kind of like a shiver. So do a little shiver. That's what the molecules do. They sit there and they shiver. And if you want to think of a solid of something like ice, it really kind of helps you think about the arrangements and the temperature of a solid. The last two things we're going to talk more about, we're just going to write them and we're going to talk about them, is a solid has definite shape and definite volume. Now we're going to talk more about those two things. Why don't you pause the video and make sure you have all the notes, make sure you have your column headings, your model, and all of these bullets here. If you'd rather write molecules instead of particles, you can. It's really up to you.
All right, so this is a solid, and I said solids have definite shape.
Hey, Mr. Crouch, I want to learn about solids.
Hey, Zach, come on over. All right, Zach, this is a cube and it's a solid, and solids have definite shape. If I hold it in my hand, it's a cube. If I put it on the table, it's a cube. And if I put it on your head, Zach, it's a cube.
If I put it in this measuring cup, it's a cube.
Excellent, Zach.
So solids have definite shape, but what about volume?
Great question, Zach. Well, volume is measured by length times width times height, as we learned in the past. So this is length 3 centimeters, width 3 centimeters, and height 3 centimeters. So 3 times 3 is 9, times 3 is 27. So this cube has a volume of 27 centimeters cubed. If I hold it in my hand, it's 27 centimeters cubed. If I put it on the table, it's 27 centimeters cubed. And if I put it in the cup, it's
27 centimeters cubed.
excellent, Zach. So you learned a lot today, haven't you?
Yeah.
Let's talk about the molecules in a liquid. We're going to use orange this time because a liquid has more energy than a solid. Now, a good way to understand this is just think of water. The solid form of water is ice, and the liquid form, well, is water. And water is warmer than ice, so water has more energy. Now, we're only using that as an example. Almost everything has a solid, liquid, and gas form. So here are the molecules. I'm using circles again, but this time they're not going to be as tightly packed. Some are going to be touching, some are not. And this is how they are arranged. They're not exactly one below the other. And the molecules are very loosely packed. And this allows them to slide past each other. So let's get into the notes part. Like we said, a liquid has more energy than a solid. Water is warmer than ice. particles are loosely packed. You can definitely see the difference in between the ice or the solid and the liquid. The particles move slowly. A solid, they just vibrate, but a liquid, they move slowly, almost like a slow dance. And the particles slide past each other. The liquid takes the shape of the container, and we're going to talk about that in a moment, and it has a definite volume. All right, let's get all that written into your journal. Pause the video so that you have everything that you need for the next part.
So Zach, water takes the shape of the container.
Really?
Yeah, if you look at it here, the water is tall and skinny. If you pour it in the measuring cup, the water is short and fat. And if you pour it into the square bowl, the water becomes a square.
What about volume?
Great question. The volume in the square bowl is 100 milliliters. If I pour it into the measuring cup, the volume is still 100 milliliters. And if I pour it back into the graduated cylinder, the volume is still 100 milliliters.
What if I pour it on your head, Mr. Crouch?
Yes, the water on my head plus the water on my shirt plus the water on my pants all equals 100 milliliters.
Okay, I get it now.
All right, the last one we're going to talk about is gas. And the molecules in the gas I'm going to use red for because gas by far has the most amount of energy and the most amount of heat energy, and I think red does well for representing heat energy. So this time the molecules are going to be very, very loosely packed, all scattered. And I'm even going to put some above here. And the reason I'm doing that is because quite often gas escapes what it's in. Have you ever gone out to a bike tire and you have a flap, but yet there's no hole in the tire? That's because the gas escaped out of the bike tire. So as we said, it has the most amount of energy. The particles are very loosely packed. The particles move around rapidly. And again, think about steam above a pot. It takes the shape of the container. And we'll talk more about that in a moment. No definite volume. We're also going to talk about that in a moment. And lastly, can be compressed. And we're going to talk more in detail about the last three in just a moment. So let's go ahead and get these notes copied. Pause the video, and I'll see you in a moment. Zach, like a liquid, a gas takes the shape of the container. You know what that means?
I think so. It means that when the gas is in this basketball, it's a sphere. And when it's in this football, it's an oval.
Right.
And when it's in the bike tire, it's circular.
Absolutely. Zach, you know, solids and liquids both have definite volume, but gases don't.
What do you mean, Mr. Crouch?
Well, pick up that red basketball. Is it full?
Yeah, I think so.
All right, well, put that back and pick up the blue one. What about that one?
It's more full.
More full. That's right. Because no matter what, you could always seem to get a little bit more air inside the basketball. And that's because you can compress the gas molecules. And since you can do that, there's no definite volume. You can always seem to get a little bit more air in there.
That's pretty cool.
Okay, are you ready to dance? We're going to do a solid liquid gas dance. And the reason for the dance, or the purpose of it, is to show you the different energy levels of the solid, liquid, and gas. In a solid, it tends to be more of a vibrate. In a liquid, it's almost like a slow dance. And in a gas, it's like a fast dance. So a couple of rules. If you're in school, stand an arm's length away from other students and stand in next to your desk and in place. If you're at home, know your surroundings, get your parents' permission, stay away from dangerous areas, and watch out for breakable items. Obviously, use common sense and be safe.
And now we have Miss Jeannie to do the solid liquid gas dance. Are you ready, Miss Jeannie?
Ready, Mr. Crouch.
All right, so I'm going to tell you what you have to do. So for a solid, you have to do a nice slow shiver, because that's how the molecules are.
This?
Yep. And for a liquid, you got to do a slow dance.
This?
Good. and the part everyone loves. And for a gas, because the molecules move very quickly, you got to do a fast dance. Gas. All right, so stop. Now I'm going to mix it up a little. Okay, you ready? See if you can follow directions. All right, the molecules shiver in a solid, so solid. Okay, the molecules move slowly in a liquid, do liquid. And the molecules move very quickly in a gas. Show me a gas. Show me a solid. Show me a liquid. Come on, everyone join in. Show me a gas. Liquid. Gas. Solid. Gas. Solid. Gas. Liquid. All right. Great job, Machini. Thank you very much.
Thank you.
Okay, it's time for your journal entry. So title it 3 States of Matter. And what you're going to do is you're going to make a Venn diagram. You're going to label 3 circles. One of the circles will be solid. One will be liquid. One will be gas. And the directions say use your notes to make a Venn diagram to show the similarities and differences of the 3 states of matter. And I made a list here of all of the things that you could put in a Venn diagram. If you have your own ideas, that'd be great. Good luck, everyone. All right, I hope you learned a lot today about the 3 states of matter. If you have any questions or comments, email me overthetopscience@gmail.com. I'd love to hear what you think about today's video. It was obviously a little bit different. There was some humor in there. I'd love to hear what you think. Also, if you want to send some video of you doing the solid liquid gas dance, that'd be awesome. Give me a thumbs up below if you enjoyed the lesson and found it helpful. If you didn't enjoy it, please email me some suggestions. I'd love to hear them. Take care. Happy science, everyone.